Okay, check 1 2, check 1 2. Testing, testing. This should be a great stream tonight. I realize that was a bit of a long intro, but please hit the like button. Share this with anybody who you think might find it interesting. I'm doing that right now. It helps fuel the algorithm to hit the like button. Comment in the chat any questions that you might have. I always get to all the questions in the chat on the side, and if you have any questions afterwards, please put them in the comments down below. But this is a stream that I'm very excited for tonight, and I normally don't like to do this a conversation about the same person or even hosted by the same person twice in a row. Sometimes it happens, but if a great conversation comes out that I want to talk about, quickly, then that's how it goes. And this was a great discussion. Last week we did a stream about Stephen Greer and Curt Jaimungal's discussion, and that was a good stream. And this week we're going to discuss another stream by Curt Jaimungal. It was his 100th episode of the Theories of Everything podcast, show, stream, whatever you want to call it, which is a huge accomplishment, that considering how much effort goes into each one of those. It's not like he just gets on a live and just talks like riffs off the top of his head, things that may be true, might not, like I do. But there's a lot of preparation that goes into it. There is increasingly more preparation that goes into this show, actually, I will say. But it's not the same level. And so congratulations to Curt for the 100th episode. But it was a great 100th episode, and I really want to discuss it because it was, I will say, I tried listening to the first episode that he did with Salvatore Pais, and I was very distracted at the time for some reason. Something was going on in my life. I can't remember what it was, but I remember not being able to fully digest all of it. And you will see a bit of that here, though, that he is kind of a next level thinker. If you don't know who he is, we'll do an intro, but he is the guy who authored the patents that the Navy filed for, they call them the UFO patents, but it's for some gravity manipulation type of craft. If you've ever heard of the TR-3B, it looks like the patents for the TR-3B. But I've always questioned why they would even be released. It sounds almost like a psyop to me, but it is pretty clear that Salvatore Pais is brilliant. Everybody's right and wrong about different things, but so I'm not endorsing all of his ideas, but I'm just saying he thinks on a level that I have a hard time following. But he had a discussion on here with Curt and also with Stephon Alexander. And Stephon Alexander is a theoretical physicist and professor and jazz musician, apparently. And he has a theory of everything, essentially, that is called the Autodidactic universe. And we're going to get into why some of his responses in this are odd, considering that his theory is the autodidactic universe. The autodidactic universe means a universe that teaches itself. Okay, that sounds like a being. It blows my mind that physicists will say things like that, but then they'll go as they'll never acknowledge the beingness. And I don't mean being like it exists. I mean being as in a sentientness of the structure that they're discussing, even though they'll call it, the universe that teaches and that learns and teaches itself. It's what learns and teaches itself? but still, we'll get into it. But I do like the direction of that theory. But this discussion was unexpectedly incredible for many reasons and just interesting as well. So we're gonna really dive into it. Um, so we'll go through everybody's background. Let me pull up the okay. So this is Salvatore. So uh, he's kind of a mystery because most of the work that he does is classified. But this is Salvatore Pais. Um, he's an American aerospace engineer and inventor, currently working for the United States Space Force, also the Navy, I believe, and the Air Force. He formerly worked at the Naval Air Station something. Um, His patent applications on behalf of his employers have attracted international attention for their potential military and energy producing applications, but also doubt about their feasibility and speculation that they may be misinformation intended to mislead the United States adversaries into you know, a scam essentially. Um, Design of an experiment for observation of the thermocapillary connection phenomenon in simulated floating zone under microgravity conditions in 1993. That was his thesis. Dang. His PhD in mechanical and aerospace engineering. This is some images from the patent. And it is very, the patent is pretty intense and dense. The Pais effect. Controlling the accelerated spin or vibration of electrically charged matter, high energy electromagnetic fields can be produced. Here's the patent. I believe. Actually, maybe this is it. Stop. Gosh, ads. Patent application. Here we go. Oh, I guess this is it. No, this is not it. Here, there. The UFO patents. Just some images of it, I guess. It's up there. You can find it. I was looking at it earlier, but I'm not exactly sure where it is. But he is the creator of the UFO patents. This is the stream that we're discussing, quantum gravity and unification, with Salvatore Pais and Stephon Alexander. So for Stephon Alexander, let's go and look at his background. I've done a stream on him before. He's friends with Brian Keating, who I know from just working in the past. I do know that, but I don't know him personally. I don't know Stephon Alexander personally, but cosmologist, theoretical physicist, musician, and he wrote a book called The Jazz of Physics, I believe. And here, let's do this. I have his paper. Autodidactic universe. This is his paper. I haven't read through it really, but I have read the abstract at some point. The Autodidactic Universe, Stefan Alexander and others, Elise Smolin. And it says, we present an approach to cosmology in which the universe learns its own physical laws. It does so by exploring a landscape of possible laws which we express as a certain class of matrix models. We discover maps that put each of these matrix models into correspondence with both a gauge gravity theory and a mathematical model of a learning machine, such as a deep, recurrent, cyclical neural network. This establishes a correspondence between each solution of the physical theory and a run of a neural network. The correspondence is not an equivalence, partly because the gauge theories emerge from n to infinity, limits the matrix models. Fair enough. But I think that we can get into that later. We discuss in detail what it means to say that learning takes place in autodidactic systems where there is no supervision. We propose that if the neural network model can be said to learn without supervision, the same can be said for the corresponding physical theory. We consider other protocols for autodidactic physical systems, such as optimization of graph varieties, subset, blah, blah, blah. Okay, these protocols together provide a number of directions in which to explore the origin of the physical laws based on machine learning architectures. Okay, so is that okay? That's everything here. So interesting, and that basic. It's funny because I talk about education all the time, and I'm not shy about my disdain for our education system. Like, I need to stop clicking my pen, sorry about that. But my disdain for our education system, and I do not believe that it teaches you to learn. I believe that it teaches you to memorize and take orders, and it robs you of your ability to learn how to think. And that's because it robs you of the time, and it robs you of the activity necessary to learn how to think. And I've done discussions on here with Will Roosh, who's he's a high school teacher and also a political commentator. And we've talked about education, and I do not believe that it is possible to teach someone how to learn. Basically, I mean, you can help them, but you cannot be taught how to learn. You have to learn how to learn. And you do this through trial and error and through exploration, exactly what he said in this abstract, where that the universe learns its own physical laws. It does so by exploring a landscape of possible laws in which we discuss in detail what it means to say that learning takes place in autodidactic systems where there is no supervision. This sounds like the opposite of school, okay? And so I agree with Stefan Alexander, although I will say, like, if the universe appears to be like a neural network that is learning or teaching itself, then we have to take that next step. We have to. Like, this is what Clear Irwin said. He's like, the universe appears to be some type of consciousness, but that doesn't mean we have to anthropomorphize this consciousness. Anthropomorphize does not mean to attribute purely human characteristics. So anthropomorphize. people talk about this all the time in the world of animals and stuff. It says to attribute human characteristics or behavior to it, God or animal or object. And this is wrong. Okay. Human characteristics that are associated with anthropomorphizing anything are not human characteristics. They are sentient characteristics. They are emotions and goals and thoughts and friends. It's funny because in the world of animals, they'll say like if you study reptiles in the wild, you'll find that like a mouse and a snake will live together. And every day that mouse will go out and collect food, and the snake will go out and hunt mice. And then at the end of the night, they will come together and live together, and that snake will never eat that mouse. And I've had this happen one time where I tried to feed a mouse to a snake. This was many years ago. I was very young, and I only had one snake, and I don't feed live rodents to my snakes. I buy them frozen. But at the time, I didn't always do this, and I tried feeding a live mouse to a snake that I had when I was like 10. And the snake and mouse decided that they were going to be friends. And like they were friends. I kept both of them in the same cage. And this happens in the wild too. And people who are biologists will say, they'll criticize people who say that those two animals are friends. And they'll be like, that's anthropomorphizing. Don't do that. But that's crazy. Friendship is an attribute of sentient beings, at least on the organism level. Your dog has friends. People will be like, oh, don't anthropomorphize your dog. It's not a friend. It's a pack member. It's like, what do you think a friend is? But if you're going to say the universe is a consciousness, or you're going to say it's a self-teaching or a learning neural network that truly learns, not as an algorithm, but is learning like we learn, okay? Not as in machine learning like we think of it today, which is just fancy math equations that are, perpetuate, but truly learn in a generally intelligent type of way, then you have to anthropomorphize it. All of a sudden, you're dealing with a sentient being, and a sentient being has emotions, and it has everything that comes along with those emotions. Friendship, romance. I've had snakes that they were like in love. And you can tell, but you have to watch them all day long, every day for, their entire lives. I sent away a python that I've raised recently here to a new home because I lost my male, and this guy had males for her, and but the male that I had for her originally, I raised the two of them for 13 years. 13 years. From this big to 8 feet long, 13 years, every day seeing that snake, basically. Watching them, even without limbs and without making noise, you see them and you're like, they're cuddling. Like they're cuddling just to cuddle. They're not like, you can't say they're huddling together for warmth. They're cold-blooded. They don't give each other warmth like that. Like they're not doing it to breed because they're not breeding. They're just cuddling. But people will be like, don't anthropomorphize them. You have to. This is a huge problem in all fields, including physics now, which is funny because you would never have thought that it would be a physics problem, but it's a huge physics problem. Anthropomorphization, the issue is the word. If the definition of anthropomorphize means to endow with human qualities, that's the problem. Because the so-called human qualities that we think of when we're thinking about what it means to anthropomorphize something are not human qualities. That is the issue. So many the issues with these conundrums that seem to be continuous that I've talked about on here have to do with the fact that we have bad words that are the intrinsic constraint of the problem that they are associated with. So in this case, it's like, how do you anthropomorphize a universe if the definition of anthropomorphize means to attribute with human characteristics? It's like, it's obviously not a human, but is it a sentient being? And are those things that you call human characteristics, are they really just human characteristics? Do you think that animals don't have aesthetic preferences and emotions and anger and fear and romantic partnerships and friends? Like, do you think that the universe wouldn't have those things too if it is a conscious sentient being? So there's issues, but I would say that we have to anthropomorphize it, and humans are the thing that we know most. They are the sentient being that we know most because it's us. So maybe it's fine to call them human characteristics, but we have to recognize that they're not actually human characteristics. We know them firsthand as human characteristics. But, my dog smiles. Like, they both smile. Like, I don't know if you have dogs, but if you have dogs, does your dog smile? Like, I think every dog I've ever had smiles and feels guilt and, feels excitement and has friends and has other dogs that they also don't like specifically. It's like, it's just, that's true of all of us. You go to the dog park, there's bullies. Like, that's not anthropomorphization. It's just sentient reality. So, this is just something we need to think about more. But I agree with him here, though, about like, learning takes place in an autodidactic system where there is no supervision. That doesn't mean really no supervision. It means like, it's the wrong words. It takes place in an environment in which you are free to pursue leads, essentially. So, like, if you're like, oh, I wonder what would happen if I did this, and you have to be allowed to do that thing and then perceive the consequences in order to learn. You can't be held back and not allowed to do the test because, I don't know, the insurance companies of your school like won't allow it, and then you're expect to learn. Like, if somebody's just like, don't do that, you're not going to learn. Every parent knows this, because every parent, countless times tells their kid, don't do that, because if you do, you're going to burn yourself. Don't do that. If you do, you're going to fall. It's like, your kid doesn't ever learn from that. They learn by disobeying you and then going and doing that thing and falling. And so you have to be allowed to pursue leads. And it's not that it's absent supervision. You can have a guide in learning, but you cannot have a controlled environment to the point where you're not allowed to pursue leads. You can have, though, people there or others there who you're interacting with, and but supervision is not the right word, I don't think. But I get what he's trying to say. But it's more about like, what are you allowed to do, not so much what are you not allowed to do. And here it's just written as what is not allowed. But it should be written about highlighting what must be allowed. So I'm a big fan, though, of this idea. It's perfectly in alignment with sentient singularity theory. And everything from the when he's talking about matrices, and we'll get into it. But first clip. Anthropomorphize. We need to start anthropomorphizing every being. And also, that includes like atoms. And if you anthropomorphize atoms and you study protons and neutrons, and then you go and you look at men and women, you will understand men and women way better than anyone else who doesn't look at it like that. but you have to anthropomorphize them. Okay. First clip is right here. This first clip is about a letter that was written by Isaac Newton to his friend, and this is probably one of the most interesting, if not the most interesting part of this entire discussion. And here.
Lack of knowledge deep within physical theory, but what if it's not just about quantizing the gravitational field or geometrizing the quantum, as Dr. Weinstein, Eric Weinstein says? What if it's about something else as well? What if there is a superforce, a force of unification that somehow combines all four forces, given that the force of gravity is acceptable as a force and not just a space-time curvature and so forth. And this superforce could be, for example, Isaac Newton. Let's go back to way before, all right, circa 1693 AD. Thank goodness for that. 1693, he writes a letter to one of his buddies, Richard Budd, I think Sir Richard Bentley. He says, what if gravity is the result of an agent, big A, capital A, that acts constantly throughout the universe in accordance to given laws of nature? And my question is, what if this agent, capital A, is the superforce? Now, Professor Abai Ashtekar, which by the way, I think quantum bounds should be called Ashtekar bounds in the LQG and loop quantum gravity.
Did you hear that? He said that Isaac Newton, who was widely regarded by many people, I'm not saying this is accurate, but as the smartest person to ever live. He was a polymath to a degree that we just do not, we almost don't even have today. We might not even have today, actually. I don't think we do. And he writes to his friend in 1690 that he thinks gravity is the result of an agent. He says capital A agent. Okay? And what this means is God. Okay? And what's interesting about this is, we'll listen.
Maybe from ignorance or lack of knowledge.
We'll listen one more time, real quick. I wrote this down almost word for word in 2018. That I had this an epiphany about gravity and God, and basically exactly what Isaac Newton wrote. And but people take this. I'm not calling myself Isaac, like on the level of Isaac Newton. I'm not. My IQ is probably way off from his. I mean, who knows? It could be like 100 points off. Maybe his IQ might be, more than Chris Langan's probably. So I'm not claiming that, because Isaac Newton said this, I am so brilliant. I actually think it's a profoundly simple idea. I'll explain how I came to it in a minute. But I agree with this, and but the reaction to this statement in this interview is very interesting. It's kind of exactly what I expected, but not what I was hoping for. But one more time while I find my exact clip or quote.
Little, maybe from ignorance or lack of knowledge deep within physical theory, but what if it's not just about quantizing the gravitational field or geometrizing the quantum, as Dr. Weinstein, Eric Weinstein says? what if it's about something else as well? What if there is a superforce, a force of unification that somehow combines all four forces, given that the force of gravity is acceptable as a force and not just a space-time curvature and so forth. And this superforce could be, for example, Isaac Newton. Let's go back to way before, all right, circa 1693 AD. Thank goodness for that. 1693, he writes a letter to one of his buddies, Richard Bart, I think Sir Richard Bentley. He says, what if gravity is the result of an agent, big A, capital A, that acts constantly throughout the universe in accordance to given laws of nature? And my question is, what if this agent, capital A, is the superforce? Now, Professor Abai...
Okay. Brilliant. Brilliant. So, I wrote this in 2018, and I think I also wrote it in 2017 and also 2019. I just wrote it in a bunch of different ways. It's in my phone notes. It says, gravity might be the most obvious evidence of a conscious action by existence, aka God. Conscious action by existence as a totality, meaning God. Gravity is space-time existence / God consciously bending to create, is what I had said. And kind of like when you bend, okay, you move your arm, you bend your fingers, you bend your arm, you bend your legs, you bend everything that you do to do anything is a bend. Okay? You are the space-time of your cells. And you bend. And gravity looks like it is, space-time bending. But the reason why I had come to this idea is that I looked at the universe and I was like, okay, this was before I was like a really committed theist. And I said, or I guess maybe not, but it wasn't, my thoughts on it weren't so organized in a physics scientific context, I guess. And I was like, if God exists, where is there evidence? What would be evidence of God? And people will look all the time to the fine tuning and all kinds of stuff, which I think is just actually not the best evidence, even though it might be evidence. It's not the best evidence. But I looked at the universe and I was like, where can I see God's action? If he's acting, then where is he acting? And I was like, okay, so where does creation begin? If life and humans and cells and molecules and all of these things exist, where does this all start? Well, it starts with gravity. From our perception, at least, this was my thought, that gravity is pushing matter together to eventually cause a fusion reaction that then results in a star that then explodes and has a bunch of elements, spread throughout the universe that then can go on to evolve. And this is also, a continuous thing, because you look at the universe and you see gravity is pushing things together. It's holding us here, and it's pushing. It's keeping planets and stars together, which you need in order to have the evolution all the way to us. And so I was like, what if gravity is God's constant action? And it's not just the result of a particle, of subatomic particles like gravitons or something. And this made a lot of sense with the idea of dark matter as well, because dark matter, they just call it dark matter, but nobody knows what it is, and they're expecting to find particles that are super small or something like that, and that explain this extra gravitational energy in the universe that's holding everything together and pulling and when you look at the matter that we can observe in the universe, it's obvious. It appears to be that, I don't want to say it's obvious, I didn't calculate it, but it appears that there's more gravity than there is matter to explain it, and that implies that there's force coming from something else. And if it's not just little, thus far invisible subatomic particles, which it's not, then it is got to be maybe the super particle, the super force that is God, and if you think about your cells and you're like, okay, this cell is attached to this cell with this amount of energy, and this cell is attached to this cell with this amount of energy, and it pulls this cell together with this amount of energy, you add it all up, and you would be like, there almost isn't enough energy maybe to explain why things are moving in your body a certain way. Because when you move your arm, it's not your cells that are making the decision. So it's not their individuated action that can explain why so much movement is happening, even though you can perceive the movement. But you are moving, and therefore your cells are moving more than they would individually move. So, according to their individuated, goals within you. And so I thought about this a lot, and I do believe it. I think that gravity is God's constant, conscious, intentional action. He's pushing things together by bending himself. And this is all. It was cool to also see that this was a thought that was shared by Isaac Newton and also shared by Salvatore Pais. And it's funny because I've talked about this before. I have like words like super literal, and I think like Chris Langan and others have words that start with super, and there's superposition and stuff like that as you get more into these metaphysics, these area of metaphysics. And I've said before that quantum physics is not physics. It's a different field than general relativity and thermodynamics and all kinds of that stuff. Like it's different than relativistic physics. It's not even the same field. So the attempt to unify it is not going to happen in the way that most people think. And that in order to unify it, you need basically God. And so what is really interesting, though, is that Salvatore Pais is saying exactly what sentient singularity theory says. And to prove it, I'll show you. He says, what if the four fundamental forces in physics, if you assume gravity is a force, gravity, strong force, weak force, electromagnetism, are only unified within them being contextualized around or within a super force, he calls it. I say super literal, superposition, like there's supersymmetry, now there's super force. This always implies you're dealing with metaphysics. Quantum physics is metaphysics. It's not relativistic physics. But this he says that these four forces are united under this super force. And he said, what if this agent, capital A agent, meaning being, okay, God, okay, I don't know if he would like that word, that language, but what else is it? It's an agent with agency that you're going to capitalize. Okay, sounds like God to me. This being is the super force that is responsible for the unification of all of these other forces. In sentient singularity theory, you have four primary perspectives. And these four primary perspectives are inside, outside, separate, and oneness. They are the backbone of sentient singularity theory right here. And they are defining of each other. So oneness is outside and inside of separateness. outside is separate from oneness, inside is separate and oneness, separate is outside or inside of oneness, and so they all are co-defining of each other. They're entangled. So if one of them exists, then all of them exist, is what is the result of this. Because if you have outside, then you also have to have inside, and you also have separate and oneness, because outside means separate from oneness, and it is the opposite of inside. Inside is the opposite of outside, so and it means separate and oneness. So basically, if you say that something is inside, then you also can figure out that inside, let's say you say like a fetus is inside of a mother, and that means that it is separate and oneness with the mother, and inside means it's not outside. So you now have 1, 2, 3, 4, all of them from just the one. Okay, as long as you know that they're defining of each other, you can deduce all of them from one of them. Sentient singularity theory is that these four primary perspectives are the four perspectives of every sentient being, or every sentient singularity. And it is how we orient beyond relativistic relationships with things. So like fast or slow, or big or small, or bigger or smaller, smarter, dumber, stronger, weaker. Like these are all brighter, darker. Like these are all relativistic terms, and they only exist in relativity. But orientation, more fundamentally, is beyond relativity, and you can do that with these. So like I said, a fetus is inside, is of the mother, and therefore is separate and one with the mother, and also is not outside of the mother. So like you can orient. What if this capital A agent, animating agent, superforce, is a sentient being, aka sentient singularity, and it unifies all four of these forces, which are they correspond with the four primary perspectives in sentient singularity theory. So you have gravity, which corresponds with oneness. Electromagnetism, I think, would be outside. I'm not entirely sure. I need to think more about it. Strong force, inside. Weak force, in separate. So weak force is responsible for decay, like radioactive decay, and or entropy, you could say. Even the strong force is responsible for holding protons and neutrons together, the nucleus of an atom together, and electromagnetism is responsible for holding atoms together, but not an atom, but like atom with other atom, I believe. I mean, it does a lot of things, but that's one of them. And so these correspond with these, and the unifying of these would be under the superforce, and the unification of these is sentient singularity. And when you look at sentient singularity theory, what you have is you have a single sentient singularity, perceives four primary perspectives, which then go on to be six relational perspectives here, basically, but within a 9-dimensional event. And then they go on to, within the cosmos, be this. So this is exactly sentient singularity theory, what he's talking about. And it's very cool to see. I mean, this is not new. You look at Carl Friston's work, and he has four. I don't remember what he calls them, but aspects of like a Markov blanket, and it's like inside, outside, sensing and acting, which is very, very close to my primary perspectives. Not quite as fundamental because you're when you first you need to like perception comes before the differentiation between sensing and acting, but right after that you get these four aspects of a Markov blanket. It seems like what I call a quantum of cognition or quantum of consciousness. That like 9 grid is basically a Markov blanket. So there's others that have come to similar ideas, including not just Isaac Newton and not just Salvador Pais and not just me, but it's interesting because I've said that I think that the universe is the graviton. It's the force carrier particle of gravity, and that we will never find gravitons in here because they're not very small. There's one giant one, you're inside it, and it is a being that is God, essentially. Or you could say it's a verse is also a graviton, but they are a capital A agent that is the super force that unifies it. But what's interesting is that when they go on to talk more about this in this interview, it's like the deeming of it as an agent went right over Stefan Alexander's head, which is crazy to me given his own theories called the Autodidactic universe. But we'll get into it. Next clip. I thought that was awesome, though. But I agree with him. He's right. There is a super force that is a sentient super force that is God, essentially, that is unifying the 4 fundamental forces of physics, and that you cannot unify them in any other way. Like, you can't. The reason why they've unified all the other 3 forces except gravity together, and which is the strong force, the weak force, and electromagnetism. And the reason for this is for the same reason that we perceive triality in quantum physics. So you perceive like up and charm and truth quark, and down strange and beauty quark, and electron neutrinos, muon neutrinos, tau neutrinos, and electrons, muons, and taus. Like, this triality is also present in the bosons. But we don't. I think we don't understand the Higgs boson, to be honest. But if you look at like the gluon and the photon and the W or Z boson, which is WZ boson is responsible is the force carrier particle of the weak force, and then you have the photon, which is the force carrier particle of electromagnetism, and then you have the gluon, which is the force carrier particle of the strong force. And this is also a triality. They're trying to look for gravity, but what they don't realize is if they do find like a graviton, it breaks the symmetry of the standard model. And the only way in which symmetry is preserved is if we're inside the graviton, essentially. Because then it preserves the symmetry, but allows you to keep that there's like a particle that is carrying gravity, essentially. But and that is the solution to the symmetry issue with gravitons. The Higgs has a similar problem, but there is this triality that's apparent in the bosons and the fermions, and even is also apparent in the fundamental forces, where 3 of them are due to what is going on inside of the universe. The weak force, entropy, or radioactive decay, the strong force, which is basically like the marriage force. It's like it's like romance. It's like protons and neutrons coming together into the nucleus of an atom. And then electromagnetism, that that force has to do with us interacting with the outside force, kind of just similar to how gravity we can perceive, and it's coming from an outside force. But the electromagnetism is not coming from outside, but it is due to our interaction with what is coming from outside. But then there's the nuclear force, which is between particles inside of the universe already completely, not just particles inside and the superparticle that we're within, which would be electromagnetism. But then there's also the weak force, which is, decay. But there's triality is excluding of gravity, because gravity is independent of what is happening inside the universe. Okay, now it doesn't mean that you can't see any kind of correspondence, because what you do see is you see action happening, where it appears like the bending of space-time is caused by mass. But I actually think that this is false. I think that it might be that it's caused by the universe or God, and that it just corresponds to the mass of the matter being moved, because you have to put this much energy in to move that amount of mass. So, like, if I want to pick this up and move it, it's not this that is. If you're inside the universe of me, and you're like, oh, this causes bending of space-time because it's causing the bending of Tyler's arm, and we think Tyler's arm is space-time. That is the wrong way to look at it. It's that my arm is bending because of me, the superforce that is the sentient superforce, is bending in a manner that is, going to correspond to the mass of this, because I have to move it the way that I want to move it. So, but that's why there's also this extra mass, which is, there because there's more going on than just, it's not coming from the mass that is here, even though it does correspond to some degree, because certain amount of force is required to pick up this water bottle. A certain amount of force is required to keep you, on the ground. But there's also all this extra mass that we call dark matter, but it's really not. I don't think it's really matter. It's probably the universe itself, or God, just his force of bending, of holding, things together, of animating. I've said my notes. Gravity is God animating the universe, and he's bending to create, consciously and constantly bending to create. That is animating, and he kicks it off with pushing things together to have fusion. It's awesome. Incredible. The superforce is a capital A agent. That is literally sentient singularity theory, that it's the superforce is the unifying force that of the four other forces. That is exactly textbook sentient singularity theory. Just call it different things. I'm more specific, and you could say more accurate in what is.
You can't say exactly what your position is.
What is the different? What is the force? Like, what makes the force the super
outside of it? And especially when those.
What is a super force? It's a sentient being. Like, that's what it is. It's a capital A agent. Why even call it a super force at that point? I mean, you can, but like, recognize where it's coming from. So this next clip, is about outsiders in physics, and this one is all too real for me.
On the outside feel like they have some grand idea because you generally get pitched them left, right, and center when you're an academic. And so it's difficult to separate the wheat from the chaff. With Stephon, what I like about you is that you take your cues from physics from jazz, which is that if someone throws you an idea, you play with it and you throw it back to the person. You mentioned that this is how you work with your graduate students. So this is supposed to be, or this whole conversation is an example of what would ordinarily happen behind closed doors being brought to the public. And so hopefully it's something that researchers can aspire to. So that's what frames this conversation. This this respect that is seldom shown and compassion between, let's say, academia and those who are outside when they have large ideas, grand unification.
Right. So on that note, so let me let me respond to Sal.
So I love that. This is one thing that I'm just so grateful for the current physics environment, podcasting environment, I guess, with Curt and Curt especially, I would say, but also Brian Keating and others, is that it is one that is allowing people to share their ideas who are outside of either the specific field in which they're focusing on the implications of their proposal. So basically, like, they might be a computer scientist, but then now they're a physicist, or they're a biologist and now they're a physicist, or they're a philosopher and now they're a physicist. But and also people who are totally outside of academia. That's rarer, but it is starting to happen. And I will say that when I first started this project of sentient singularity theory, I didn't know that I was going to have a theory. I had an experiment that I wanted to have done, which I still do want done. We'll talk about it when I release my paper. But then it became a theory because I realized I had to turn it into a theory, because it wasn't this. What was needed was missing from other theories out there. At first I was like, they're all saying the same thing, which they kind of are, but then there are specific things missing that from other theories out there that needed to be there for fundamental theory. And I'm doing a video. Curt Jaimungal has on his channel it's like a competition of video competition of for you make a video explaining anything in physics or consciousness, and then it's like there's, I think, $1,000 is going to each of 5 winners, and that has been down. That money is being sponsored by Brilliant. It's a pretty cool idea. I like that it's getting the community involved, and it's giving people a chance who are way outside to like participate in this. And I wasn't originally going to do it, but I've decided to do it, and I'm doing a video on what is a theory of everything, essentially, and like what is it not, what we think it is normally, but what is it really if it's different than what we normally consider it in academia. And but this bringing of this highlighting of people outside of academia or outside the field in which they hold credentials is very important to move. It's not even very important. It is necessary to move all of our fields forward, because everybody who is going to make groundbreaking moves in any field at this point basically is going to be somebody who comes from outside the academic world of that field, almost always, I've noticed. So even if that means like you are academic but you have a degree in biology instead of physics, like you're more likely to make groundbreaking progress in physics than you are than a physicist. So it's been a very interesting time, but I do know that this is when you do have an idea, and I'm not Salvatore Pais. Salvatore Pais, he has a PhD. I do not. I don't think I ever will. If I did, I'd be for philosophy, but I doubt I'll ever go back. It would literally just be to get the credentials for the sake of like the community giving me legitimacy, which I understand why that could be useful, but I'm just so resistant to it. But Salvador Pais also, he works for the U.S. government in very classified projects. He got a lot of recognition from these patents that were filed. So he does have a degree of credibility that like someone like me doesn't have. But I do understand that it sounds like he has faced quite a bit of pushback and just criticism and mockery by academic physicists based on the things that he has said here. And I totally get what that's like. But at the same time, I also understand that if you have a theory of physics or something like that, you have to find it, and you're outside the system. You have to find a novel way to get your ideas out into the discussion that you want to be a part of. You can't rely on just sending emails to like physicists and expecting them to respond to you when they get 1,000 emails a year if they're lucky, but maybe way more than that saying like Einstein was wrong and like, I understand the universe and nobody else does. And there's just no way almost to address those in like an organized fashion. But people who have so much of not just faith in legitimacy, or not legitimacy, but in the necessity or the importance of what they want to push forward, an idea that they have, but also have the ability to communicate it, will end up being heard. Like you just have to know that. You also have to have the disagreeability to push it forward. So, but if you can't rely on just emailing academics, I can say I've never tried to send my theory to or ideas to academics, and just because I knew, like, I was like, they'll never get back to me. But I didn't know exactly how I was going to do this, but it has morphed into this, which is working, which is cool. But it's still like it's like the autodidactic universe. You need to just explore the limits of what you can do as you do it, and outside of supervision if you're going to figure it out. But it's tough to be when you're at first you are mocked and just ignored, or shut down is the worst. I don't really care about being mocked, and I don't really care about being ignored. What I care about is when I'm shut out, which has happened multiple times, where I was literally banned from physics discords for no reason. I'm a pretty polite person. I try and be kind, and I was kind, and like it was just I don't know. They said I was dangerous, which means like I make too much sense, but you don't know how I'm making sense. Like if I just looked crazy completely, I wouldn't have been banned. But the thing is, though, is that like once you realize that those fields are lost, then you realize you don't really need their continuous approval. You need one person eventually who has access to the people who might be necessary to, I don't know, run an experiment that you want to do, but you don't need to get a lot of support from like a bunch of physicists or physics professors. You just don't. And I have access to those physics professors. And like I said, I've worked with Brian Keating. I don't send him my theory. Like if he knows it's there. If he wants to look, he can look. But like, you can't just rely on that. They have too much going on, and the amount of investment that it would take to look into your work is just it's a lot. This is what Eric Weinstein is facing too, but eventually you do have to look at how the amount of sense that people are making if you're willing to engage in a dialogue with them at all, and be like, okay, you are somebody then I should take seriously. Like Eric Weinstein, physicists should take him seriously. Obviously, he's very well versed in physics, but if you have to some degree speak the language, it's a tough road when you're outside of academia. I get it. But I appreciate that there's people willing to highlight that there's more, that there are people who can make contributions to fields who might not have PhDs in those fields, even if they do have PhDs in other fields. Okay. This was also interesting to me. It's about string theory, and it's what it really is about, kind of, which is what I expected.
That underlies those three forces, right? And the super force, this unification of gravity with these other three forces. This was actually the program of string theory, right? String theory and its parent, when some people call, I think I find its parent theory actually very interesting, matrix theory, right? The idea that, what underlines the overarching framework that that string theory comes from is a matrix, quantum mechanics. So now I think what is interesting about what you're saying is that there's one thing to say that forces, including gravity, are unique.
By the way, this is a matrix. This is a matrix. This is calculating. It's not just like numbers. You put a 1 in there, and there's nothing. Put a 1 in there, there's that. Put a 2, 6, 7, whatever. But what this is it's showing when you click on this and you're like, okay, this is an entanglement point between information coming from here and information coming from here. This is a string that basically of information that runs from here through to here and is forming like interactions and knots or excitations and creating new information from one string or one loop. And the same thing goes with this. So every single one of these is calculative. You make this a 0, everything changes to 0. Make this a 2, everything changes, and to 1, everything also changes. So there's a string of information that is going through every single cell here in this matrix, essentially. And somebody once told me that this looked like a packing fraction of for a fiber bundle, which sounds right. Which is basically like, instead of a string, you're just relying on quantities or cells in this case. But there is a string that connects this one to this one, and a string that connects this one to this one, and a string that connects this one to this one, and that one to that one, and then that one to these ones, and then this one to that one. So like there's a string you could imagine going here, and it's just weaving, literally like a rug. You could weave a rug with one string, but it would be like the fabric of space-time that you're weaving. And in this case, it's the fabric of information and sentience, basically. It's the sentient fabric instead of the space-time fabric, which is kind of more metaphorical, whereas this is more literal, super literal. But I think Brian Keating calls this I think he said it looked like the cosmic macrame. Which is funny because we call it, fabric of space-time. It's like, okay, I don't take that as an insult. Somebody suggested in our Discord community that I make this binary basically, and so I did, and this is what was created. Just side note. Very cool. What you can tell is this is a double helix structure. It's a spinning double helix. That's what it is. And you can really see that here, where like when you look at it in a binary fashion, you can see that there's a twist here. In just looking at it, it's fascinating. But more on that later. But yeah, matrix theory is the father of string theory. Apparently, it's also seems to line up with general fiber bundle theories, based theories like geometric unity, or which is similar to It's also E8. E8, Garrett Lacey's E8 theory. He suggests that E8 shows the symmetry patterns of particles, which are actually excitations of strings inside of a fiber bundle, okay, which is a mind. This is a fiber bundle. It's self-reflective. It's a 4 by it's a knot of 4 with a knot of 4 within it. It's like when you think about yourself, you're thinking about a little version of you inside yourself. So that's what I meant by like they're all saying similar things. But here, next clip. This is what I mean by I was just shocked by like how this just went, the idea that this was an agent just went like this.
So now I think what's interesting about what you're saying is that there's one thing to say that forces, including gravity, are unified, but your perspective, what I'm hearing, your perspective is that you're calling that unification a superforce. And therefore, I'm going to ask you, what is that force?
Okay. Thank you, sir. Thank you very much for this. Wow. Wow. Okay. First of all,
I hope it's not computational biology.
He said exactly what it was. He said it's an agent. He even said capital A agent.
No. Oh, wow. We'd have to involve Dr. Wolfram, some other notables in it. Maybe. By the way, down the road, if you could discuss your idea of the.
Okay, hold on. Next clip. But he doesn't really get in. He doesn't really explain it. He's just
what
like,
I'm trying to say is that what is the Planck force doing in the Einstein
he should have been what
equations if it wasn't a bridge between
what Sal Pais should have done when Stefan Alexander asked, what is that unifying superforce? He should have said, it's a sentient agent that is constantly acting, consciously constantly acting on the universe. Like, that's what he should have said, but he didn't. He just kind of repeated himself that it's like the super force that unifies things. And but we're gonna get into more details of this stuff now. I went a bit like in depth about what he's said already because it was awesome, those clips in the beginning. But that's how you should have responded. I don't want to get too into it, but why not just admit it? Like, I've seen so many people do this. Eric Weinstein, Clear Irwin, now both of these two. Like, if you're gonna call it an agent, or you're gonna say that it learns, or you're gonna say that it's conscious, or you're gonna say that it's almost sentient, as Eric Weinstein says, or you're going to say that it's that a fiber bundle is a mind, but you're not really gonna outright say it, or you're gonna say that it has taste for beauty, like, then double down. Don't dance around the idea. State it.
The world of the very small, quantum mechanics, and the world of the very large, general relativity.
Okay.
Okay. This is important to get at because this is related to even the video that I'm making. This idea is false, that quantum mechanics refers to the world of very small, and that general relativity refers to the world of very large. And this is not true. It looks true, but it's not. It's only because we're looking at a spot in the universe that is orders of magnitude on basically like scales below us, objective scales below us, in size, you could say, and also in complexity. But when we look at hadrons and quarks and things like that, but quantum mechanics is not about the very small. Gravity is not about the very large. Quantum mechanics is about information interaction, okay, between sentient minds and the relationships between those information interactions between them. Gravity is a physical, it's like a super physical force, okay? It's more material in the way that we think of matter than the material world than even quantum mechanics. Below, at least when you are looking at things like just the standard model at the elementary particles, those are excitations on a fiber bundle. That fiber bundle is a mind, and it has to do with crossing strings of information. That is not about the very small. You can observe quantum mechanics and the same exact patterns when you look at people. That's what I said, like females, human females are the same thing as neutrons, and human males are the same thing as protons, or they are an expression of the same gendered sentient force on a different scale, but it's the same being, essentially, almost. It's scaled up in its complexity, but the patterns of behavior are the same. And nuclear fission is feminism, guys. It is feminism. That sounds crazy if you're not new to this stream, but or even if you're not and you haven't been here recently, but free neutrons colliding with other, atomic nuclei to blow them apart and create more free neutrons, like, this is feminism, destroying nuclear families. It's happening on our scale. We're inside of a fission reaction. This is quantum mechanics happening, but we are the particles. So it's not about the very small, and gravity isn't about the very large. It's just totally different. They're not even the same. They're not even remotely the same. They're so far apart that they're basically different. When you examine them, you basically in different fields. If you're examining gravity, you're basically in the world of relativistic physics. When you're examining this standard model, you are in the symmetry patterns in it. Quantum mechanics, you are in metaphysics. But where gravity morphs back into metaphysics is when you start talking about like dark energy and dark matter. But that's not the apparent noticeably one-to-one corresponding gravity. That, it's a little different. But it's not about the very small. Quantum mechanics, you behave in a quantum mechanical way. You, if you're a male, are proton, and women are neutrons, and the same patterns follow them. When I first started this, as I've said before, I predicted that there would be no isotopes of elements where there were more protons than neutrons, but there would be some where there would be more neutrons than protons, but most of them would be 1-to-1, where there'd be equal numbers of protons and neutrons. This is exactly what we see, and I predicted it in physics, and or chemistry, whatever you want to call it, when it comes to elements. I predicted that based on looking at humans. Okay, so quantum mechanics is not about the very small.
So, I mean, I think, dimensional analysis is always a great path to take when we're trying to understand new things about that the theory may not be saying, right? So scale analysis and dimensional analysis is, I think, a great way to proceed. One question I have, of course, is that no matter what you do with the Einstein field equation, right, you can always, I mean, at the end of the day, right, and a good exercise just to walk everyone through this. On the left-hand side of the Einstein equation, we have the notion of curvature, or, let's say geometry, is related or equated with, right, energy momentum, right, matter and, and energy. So, typically, I mean, when we, at least bread and butter relativists and cosmologists that I am, we tend to use fields or fluids to discuss that framework. So we have, on the left-hand side, we have the equivalent of a field, in this case, the dynamics of the gravitational field, seen through the lens of curvature. And on the right-hand side, we have like basically fluids or fields, matter fields, right? So, and then, of course, we have matter or fields or fluids, whatever, right? Space-time, and basically the system is nonlinear, and there's what we call back reaction. The matter can curve the geometry, and the curved geometry makes the matter move, and then that in turn, back reacts, right? So you have, because the system is nonlinear. Right. Now I can choose to put vacuum energy, or the cosmological constant, on the right-hand side, right? And it appears to behave like a...
If you look at a video of mine, it's called Gravity in the Observerse, I think, that is early on in this channel, I talk about this, that it makes sense to think of gravity, or that of the universe, as a fluid, and I talk about how that can help you understand it. But here. Next clip. I'm not trying not to go super late because I have a lot to do still tonight, but so I'm jumping around a bit, but we're still gonna have.
Then what it says, it's the superforce acting on the spatial temporal geometrical structure that gives
a good stream. Here you go. This is awesome.
Then what it says, it's the superforce acting on the spatial temporal geometrical structure that gives rise to matter, to energy density. That's a whole different look, a whole different understanding of what GR has been telling us. It's a new perspective on old physics, not new physics. I cannot stand when people use the idea of new physics.
I love this. This is so cool, guys. Okay, so this is exactly what I said about thinking about, don't think about the weight of this curving my arm. Think about my arm curving curving based on the weight of this. But it's coming from my arm. It's not coming from this. And that is a whole new perspective on thinking about gravity. And but when he's talking about space-time acting on itself in order to create energy density or matter. This is exactly what sentient singularity theory states, is that God bends in and basically like divides himself and acts on himself in order to string a knot together, essentially, that is self-reflective and then creates sentient, sentience once you get it to at least a hadron. But prior to that, when you have quarks, this is just a focus point. I don't call them, like people say that it's like a subatomic particle. That's not a good way of thinking about it. A good way of thinking about it is it's a focus point. It's it's a force point. Okay, that's what I usually call them, as a force point. A quark is a force point. It's a point of force. It's God's finger is poking and creating a point of force. And so what it is that you have in quarks, you have two ups and then a down when you're going to get into proton, and then two down quarks and then an up quark in order to get a neutron. And this is a right hand and a left hand with two fingers and a thumb, okay? And you have to have two fingers and a thumb in order to manipulate things. Try doing it with just two fingers. Try doing it with just a thumb and a finger, and you're severely limited. But as soon as you have two fingers and a thumb, you're more mobile and capable of maneuvering and manipulating than you are if you have four fingers and no thumb, because you need that opposition of the thumb to the fingers, and you need the fingers to also triangulate, which is why you need three. But this is exactly what God is doing. Like, Eric Weinstein once was in a conversation with me on a Discord call, like, very long time ago. And it was a profound moment. Like, that conversation between him and I used to talk about it. I don't talk about it as much anymore because he shared things that he doesn't say publicly, which he should say publicly about geometric unity, but he doesn't. And if you followed my streams, then you know what I'm talking about. Maybe I'll talk about it again. But even though I think it's wrong that he doesn't say what he said to me there, like, he did, it's not necessarily my place to, like, be blasting it, but I might start doing that again. I have stated it. I've talked about that conversation before, but once he asked me, like, what he asked the group, like, what do you think quarks are? And I was like, or why, he said, why do quarks not appear alone? Why do you not find just an up quark sitting by itself? Or a down quark sitting by itself, and it's always with other quarks. It's always two up quarks and a down quark, or two down quarks and an up quark, together in this triadic grouping, and or at least they're in a grouping, but and I had said, like, I think I actually know that, and people were like, shut up, Tyler. Like, this was one with the Discord where I was banned by it, and it was like a physics Discord, and people were not happy about it. But props to Eric. He was like, no, I want to hear what this guy has to say. And I couldn't get my words together because I wasn't ready for, it was just off the cuff answer, and I was pretty new to discussing this with anybody at the time. And I said, it's a superposition, basically. Each quark is not a different thing from the other quark. It's like they're separate parts of one thing, which is true, and was my answer. But what I should have said is, it's like, for the same reason you don't find a finger just chilling by itself, you always find a pointer finger and a middle finger, together next to a thumb, unless it's a mafia movie and people are losing their fingers. But otherwise, you always find them together, and the reason why is because they're connected to the same hand. But if you don't know that they're connected to the same hand, and all you see is like this, and you're like, you think that this is a separate thing, this is a separate thing, and this is a separate thing, but it's not. They're really connected to one hand. And that is why you don't find quarks by themselves. And that's a much better answer than what I gave at the time, but it took me time to figure out how to word that. these individual points of force are God acting on himself or it's space-time acting on itself in order to cause an energy density or a point of force that is matter. What we call matter. The fermions, the quarks, which includes the quarks, are considered the matter particles. And, we can get into another time what, those are, other than just the fact that they are points of force by the capital A agent that is the superforce of the universe, which is a sentient singularity or a sentient being. It's God. And a proton is basically his right hand, and a neutron is his left hand. But whether or not God's hands are sentient at that level is a question. It's hard to know because they would look the same regardless. But I think that it's safe to say that you can at least they probably are sentient. Atoms definitely are, but hadrons might be. But regardless, they display the same patterns of behavior as sentient beings. And the thing is if they're hands of God and God is a sentient being, then they are sentient, but it's whether or not you're looking at a hand, which is not really sentient, but it's connected to a sentience. And, but even then, they might also be individually sentient. The thing is, though, is that it might not matter at that point, where it might just be probably the answer is both. Almost certainly. It's like, are they the hands of God, who is a sentient being, or are they sentient in and of themselves? Or both. And the thing is that that's the actual possibilities are they either are the hands of God and they are individually sentient, or they are the hands of God, who is a sentient being. And those are the only two options. It's not actually three. It's two. But again, this guy talking about sentient singularity theory, not even knowing it, Salvatore Pais, like really detailed too, especially that beginning. But that new perspective on old physics is a great line. I talk about that all the time. I almost use the same language. I've said before, my philosophy professor said that philosophy is the study of perspective, and I have 4 primary perspectives. Like my whole theory is about like exploring perspectives. And I told Eric Weinstein once in another discussion that's on his Instagram, my first discussion with him, I was like, a dimension is a perspective. And he was like, no, it's a degree of freedom, actually. And that's not false, but the thing is that I didn't have the ability to push back at the time, and I didn't want to, because I was just wanted to hear. I had a question for him. I wanted him to talk about his observers. I didn't want to tell him my ideas. I just wanted him to explain himself. And but it's really that a dimension is a perspective which is either a degree of freedom or a constraint. And that's what a dimension is. But I mean, you could maybe say that a dimension is only a degree of freedom, but it's so intrinsically tied to a constraint that you almost, like, it's like saying like a hallway is a degree of freedom, but the walls are a constraint. Okay, but there's no hallway without the walls, so there is no degree of freedom without the constraint. So that's why when I say like a dimension is a perspective of looking down a hallway, that's your perspective, like, then that's correct. It's just you need non-physicists to like talk about this, who also talk to physicists. This was interesting, this comment by Salvatore Pais criticizing Michio Kaku a bit. I thought it was funny. But I don't really get what he's trying to get at, but I'm just going
This
to
is
highlight it.
something that was brought up several times, but also Michio Kaku keeps on saying, for example, that LQG leads to lack of fermions. It basically doesn't show fermion. I don't see it either. I mean, for God's sake, this comes from the guy with a God equation. You know, you thought. Anyway, I'm not gonna go there, but anyway, I don't see his point. I mean, I think Dr. Weinstein has some ideas with this geometric unity, with with making LQG yield, because he talks about these family family of three fermionic families, something of that nature.
Yeah. So I guess maybe what Michio Kaku is probably talking about is how to formulate fermions. Because in loop quantum gravity, you're using these gravitational Wilson loops.
Everything is loops and strings and bundles. But I mean, I don't know what he was getting at with Eric's statements about triality, but I mean, Eric is basically stated that there's triality is an illusion and that it's really a duality. But it's, as I've said before, it's a dimensional triality, but it's a duality of degrees of freedom, and one of them is and then one constraint. So like, that's what sentient singularity theory posits, at least. So I understand why he says what he says, but he hasn't found a good way to state it. I don't know what it's related to what they're talking about, but Michio Kaku does have has said, he wrote the book The God Equation, and he said he's constantly talking about like how the theory of everything is the God equation, and it's just always interesting of when people use that term. But what's funny is that you have Salvatore Pais criticizing, for some reason he doesn't get into it, Michio Kaku for having a God equation, and it sounds like Salvatore Pais is more of a theist than Michio, because Salvatore has basically stated that he thinks that this superforce is an agent, capital A agent. That sounds like God. Like, so I'm not saying he has a God equation, but it's interesting. I don't know what he was basically stating. But he basically says that his superforce connects everything, which is totally true. This is a comment. This is by a statement by Curt in the stream about like dealing with academics that won't won't engage with you. Basically, he's talking about Ed Witten, but we're going to get to it. Let me address the chat. What's your take on Schrodinger's cat? It's a mistake of wording. Like, it's not a cat that's dead or alive. It's a cat that is either a singularity or a multiplicity, but it's not actually or. It's a cat that is singular. It's a singularity and multiplicity. It's a multiplicity of cells and a singularity of a cat. And even if it's not, even if all those cells die, it's a multiplicity of, of molecules. Like, no matter what, it's a multiplicity. But if you're talking about it as a cat, it's also a singularity. And this idea of not until you observe it is it like dead or alive, essentially observed as dead or alive. It's just the wrong wording. What it is that, are you looking at it as a cat, or are you looking at it as a bunch of cells, or are you looking at it as a bunch of molecules? Are you looking at it as even like a bag of fluid and organs? I don't know. But more fundamentally, the multiplicity and singularity thing is what is at play there. I think that it's been so misinterpreted, and nobody understands the way that it's been interpreted now, because it literally doesn't make sense. It's not about the cat being dead or alive at all. It's about it, whether or not it is a singular cat or it is in multiple cells. But that does correspond to you, because if I if you die, then immediately you're no longer a singularity of a person, but you are a multiplicity of cells. And as those cells die, each singularity of those cells breaks down into a multiplicity of molecules. So, but it depends on your goals of what you're trying to observe, and it does dictate what you see, but it's not about whether or not the cat is dead or alive at all. It has nothing to do with that. Did you watch the Ye and Lex Fridman interview? I'm about halfway through the Lex Fridman and Ye interview. I think it's great. Obviously, I have a history with that topic, and I'm just glad to see Lex having the courage to interview somebody on a topic that's very controversial and difficult, and who he didn't invite him on there to debate with him. He invited him on there to have a discussion with him man to man with mutual respect and kindness and grace, and that is good. Like, from what I've seen so far, I'm only halfway through, but that's what you need to do. Like, people are people. You don't just, it's not everything is debate. Oh, I'm gonna have them on so that I can debate them on whether, on Judaism or something. Like, but I thought so far I really like their conversation. I'm gonna finish it after this. There are at least several examples of feeder mice and snake friends. Thank you for taking care of the bots, by the way, Torin. Although I have to say, I think if a rodent and reptile are friends, it's usually because the reptile isn't in good condition. It's likely the rodent will one day gnaw on a vital part of the reptile. No. If they're not in, when, it's like your dog and you are friends. If you are starving, I just watched Castaway with my wife last weekend. She had never seen it. And if you were stranded on that island with your dog is becoming your food eventually. Okay? If you get hungry enough and you are in bad enough condition, it's not about like, it's the opposite of what you think. It's, if you're in good condition, then you're more like, there's more friends around, okay? But if you get stranded on an island and you've eaten the dog and you're still starving and you're looking at your friend, it's like now one of your friend who's a human might become like your meal. I was reading stories about people who were cast away on islands in the past, and they had like, there was instances where they worked together and they got off the island. There were other instances where it was like a wreck and people literally like ate each other. And it's because they're in bad shape, not good shape. Same thing with reptiles. They're more, and every animal, they're more likely to tolerate, mice who they live with if they're not starving. But if they starve enough, they will eat that mouse. But here's the thing: it makes sense to do that, because if you're a snake and you're living with a mouse, and it makes sense to not just eat that mouse sometimes, because the fact that you tolerate its existence around you means that it will breed with others around it, and also then you'll have a food source. So I'm not trying to not anthropomorphize the snake and not say that they are friends, or at least very, very minimum roommates, which they literally are. That's not just anthropomorphizing. They live together. They live in the same house. That rock crevice or whatever is a house, and they live together. Like, and they tolerate each other at a minimum, but they might be friends too, but it's the opposite of what you said. Don't be too sure about your estimation about yourself. I don't know what you mean, but because I didn't address it immediately, but I try not to be too sure of myself, but I also try and be confident. I don't know what I try and be critical of I try to be critical of myself and honest about my confidence and my fears and weaknesses and stuff too. I don't know what you were specifically talking about, but I did go back randomly, speaking of just strengths and weaknesses. I went got back at the martial arts gym, got back into Muay Thai this week, and I'm so sore, guys. I've not been this sore in years, but my technique still really strong. Very confident in my technique. My cardio totally gone, very weak, but it was cool. Brains look like a big knot. Exactly. Brains look like a big knot because they are a big knot. They are the physical manifestation of the entanglement point of information in the metaphysical reality, which is, or in the quantum entanglement substructure. Your brains are the entanglement point of that information. That's why they look like a knot, because of that. It's funny because they call your gut the second brain, and if you look at your gut, it looks kind of like your brain. It's like a knot. But your gut is like the brain that is interpreting what is within you. Your brain is processing the information that is outside you, almost, for the most part. It's like what you observe and how you process it inside, your brain, so that you can maneuver and do whatever. But your gut is like, its world is the world within you. It makes sense. It's like your gut is the symmetry organ of your gut is your brain. Fascinating. Always a paradox. Sentience of quarks seems always to be both. Quarks are not sentient. They're fingers of God. But hadrons, protons and neutrons, might be sentient. But quarks are not sentient. Just like your finger is not sentient, but it's part of a sentient being. A quark is not sentient. This is like where sentient singularity theory really contextualizes like the ideas of panpsychism and materialism and idealism and stuff. But especially panpsychism is intuitively like interesting and also seems spiritually appealing for some reason, but it also is just totally not contextualized usually. But if it's contextualized well, then it actually like makes sense. But quarks are not sentient. They're not individual agents, but they are part of a sentient agent. But yeah, here, next clip. This is the Curt on talking about Ed Witten, and Ed Witten won't go on theories of everything. Then, which is crazy to me. I will just say this: like, Curt Jaimungal's YouTube channel has basically, as far as I know,
it's the whole idea of the Easter effect.
See,
it is the most rigorous and fastest growing podcast involving not physics, but also metaphysics and consciousness and theology and all kinds of stuff. But even just physics, it's the most rigorous physics podcast that I know of. Like, there's nothing that even comes close. Why would Ed Witten not go on there? Like, that doesn't make any sense. If you believe in string theory and you think it's important, then you believe that it is important to talk to the world about it. It's not just about your little in-clicks about like your own research and sitting at your blackboard by yourself and talking to your friends who also have PhDs in physics. That's not producing anything right now. And I actually think string theory has a lot to offer if it was contextualized properly, but you need to get it involved in a discussion again. But the problem is that if you did, the elitism that has been built up around it would fall. That doesn't mean that string theory and the work that's been done is useless. It just means it would be revealed that it wasn't then it wasn't as fundamental of a theoretical of a theory as it has been proposed to be.
Constantly trying to get Ed Witten to come onto theories of everything, and he always responds to me, but he says no. However, here's one way that he can come on.
Why?
Because
Why
I think
does
that
he say no?
he's just so busy. One way to have him on is by just giving one of his statements, and then I want to see what you, Stephon, have to say about it, and then same with you, Sal.
Okay.
So Ed Witten was asked about whether the lack of experimental data is the reason why there's so many candidates for quantum gravity. And then he said, I think your premise is misleading. String theory is actually the only idea about quantum gravity with any substance. One sign is that where critics have had interesting ideas, so non-commutative geometry, black hole entropy, twistor theory, they have tended to be absorbed as a part of string theory. Another sign is the way that string theory has been successful in generating new insights about standard quantum field theory and even about geometry. Okay, so I'm curious to know, Stephon, what do you make of that? What would you say to Ed if he was here? What thoughts occurred to you? And then same with you, Sal.
Yeah, I think that as a person that still publishes and I publish papers that use the framework of string theory to say to speak to cosmology, speak to some issues of how particle physics overlaps with cosmology. In fact, I'm working on something right now that deals with electroweak unification from structures that come from string theory, and how they may play out in theories like cosmic inflation. So I can't speak too much because I haven't put the paper out yet, and I'm still like fiddling with equations. But so I'm putting that out there to say that I am a big fan of string theory, and I do think that it is, from my opinion, from where I sit, the most promising and pragmatic, because it does give us a framework. It gives us technology, so that a person like myself can actually formulate research problems in cosmology, in my case, right? And how particle physics and cosmology speak to each other. However, I don't think that research at the forefront of other approaches to quantum gravity takes away actually from string theory. I think that it's important that we continue to pursue research on all these fronts, right? So I know that there are some statements that, for example, string theory is the only game in town, or string theory is the only formulation. I mean, we have things like causal dynamical triangulation, covariant formulations, non-perturbative formulations of quantum gravity. I was just visiting a colleague, Simon Catterall at Syracuse, who does Euclidean lattice quantum gravity, and they're starting to get very interesting results that can get us back to the Sitter space in some semi-classical approximation that's non-perturbative. There are, again, open-ended issues there. So again, I think that what's the word? The fact that string theory is, in my opinion, right now the most developed framework with the most workers in that field. It doesn't take away from that fact that there are other, I think, viable approaches in terms of research in quantum gravity, and they're certainly out there, and they have their problems. But that's why, as Leon Cooper said, we knew what we were talking about. We wouldn't call it research.
Euclidean lattice what?
Quantum.
I love that statement. He's like, if we knew what we were talking about, we wouldn't call it research. Eric Weinstein put at the beginning of his lecture presenting geometric unity at I think it was Oxford. He said, he quoted someone else and he said, you must recognize that if you are to do something new, essentially, then you must realize that you are by definition unqualified to be doing that which you are doing, essentially. And that's so true. But I really like Stephon Alexander. Just like, I don't know, just the way his I don't know. He seems to be onto something on his own research, but also be having an open mind to others and treating people's ideas as valuable. I think that that's very important. And the thing is in this space of like theories of everything, this was something that I realized very early, is There's so much ego in this space. I've never seen anything like it before in my life. And I come from martial arts background, fighting background. There's more ego in physics than there is in martial arts for sure. Because for one, if you're in martial arts and you never fight anybody, you're not going to have any cred anyways. And if you do fight somebody, then like your cred is tested in that, and then also fighting among men relieves a lot of tension, and you end up becoming friends with people who you fight literally. It's just a weird thing that guys understand. And so there's like a lot of ego, but there's also like a lot of humility. There's not that in physics, not in the academic world of physics. There is so much elitism, and then when you're talking about certain things like string theory, and even these other proposed theories like Erwin's, emergence theory, or Eric Weinstein's geometric unity, or Chris Langen's CTMU, or Ed Witten's work on string theory. Like, most people don't act like Stephon Alexander. Most people avoid being the man in the arena. Okay, and it seems like Ed Witten is avoiding being the man in the arena and not going on Curt's podcast. I hope he changes his mind and goes on. I can't imagine he's so busy that like multiple times he's turned it down instead of like scheduling something later on. That to me sounds invasive. I'm not saying it is for sure, but but what Curt did was, which I can't disagree with because I do that every day on my stream, is he just took a quote by Ed Witten and got, Stephon Alexander to respond to it. And when I was trying to figure out how I was going to participate in these conversations, and I do eventually want to have, more. I have done some interviews on here, but I'm planning on doing much more as our technology gets better and the channel grows. But to start, I had to, in order to participate in these discussions, I do this, where I go and I give my thoughts on other discussions that are currently happening. But I also have my own work, so I think that is important. I'm not just here as a critic. I try not to be a critic. I try and talk about what I think is good. I'm not here just like shooting down theories. And I actually think that all these theories, including string theory, like I said, has a lot of value, and it's more about contextualizing them. But everybody wants their theory to be the theory. And I'm already telling you, like sentient singularity theory, I do believe. I don't even feel like I have to defend it. The issue, that doesn't mean I will be attributed with the idea. I mean, somebody might change the name and they might just call it God theory or something like that. But at some point, or sentient superforce theory. But if they did that, like, it's sentient singularity theory. But it's not about me, so I'd be like annoyed that like this was happening, but I wouldn't be like, I would still be like, cool, that's exactly, what I said. It wouldn't be, this isn't an ego trip for me, this project. And the reason why is though, and I'm not saying I'm above having an ego, it is because I'm an outsider. Like, it's because I don't have my identity tied into this project, because this is so new to me, and I just feel like I have responsibility to do it. It's not like this was like my dream was to like talk about physics. This was like my last thing I wanted was to like talk to mathematicians and physicists about stuff. But for people who have invested their lives into this, I mean, there's so much ego involved, and there's so much just avoidance of tests. And the thing is that peer review is not a test. It's not the same thing as being the man in the arena, where literally like these theolocutions and that's a man in the arena. Or when Brian Keating has on Stephon Eric Weinstein and Stephen Wolfram, like the two of them discussing together, like that's the arena. But the thing is that what you come to find is that everybody's theory has like unique like strengths and also unique weaknesses or just like limits, I guess. But what's going to happen is that all these theories of everything are going to have to start not being the question isn't which one is right. It's which ones are useful and applicable, and which ones are fundamental compared to others. So, like, are strings more fundamental than I don't know, like loops, which they're like the same thing. So, like, that's why it's tough. But are sentient beings the most fundamental thing, or like what, or is math, like Max Tegmark's mathematical universe, or is math the most fundamental thing? Like, which one is most fundamental? They're gonna have to be ordered, but that doesn't discount the other theories. Like, we need them, but there's so much ego involved that like people don't even want to pay attention. They don't want to come down from their towers and step into the ring. I don't think, like, people like Ed Witten. They just want to sit there and continue to rest on the assertion that has been the case in academia for decades at this point, which is that string theory is the only game in town. And I'm a newcomer to this, so this is all like something I've been observing over the past few years. But it does, before I was involved in this stuff, all I heard about was string theory all the time, and like Stephen Hawking, and like into the universe, and the universe is really made of tiny strings, and I used to think this was so profound. And but like, strings of what? What, like, information? Okay, well, what is information? It informs what? No, informs who? Like, okay, who? Sentient beings. You have to do that kind of thing if you're going to start ordering them and contextualizing them, and they will be most useful within the context of each other. So geometric unity might be good at warp, helping us develop warp speed more so than sentient singularity theory, but maybe sentient singularity theory can help you deduce moral implications more, or like political implications. Who knows? But you should research multiple theories, and like Stefan Alexander said, and the idea that, like Ed Witten, like when Ed Witten says, well, the fact that every other theory has basically become a part, like twistor theory has become part of string theory, is credence to its authenticity, or its supremacy, or whatever the word was. Like, that is true and isn't true. What it is evidence of is that string theory is more fundamental than those theories. But even though, like I said, it doesn't take away from those theories. So, but the thing is like, what if there's something more fundamental than string theory, and then string theory has to be absorbed into that, but it's not really that it's absorbed and then it's no longer string theory. It's still string theory, but it's within the contextual framework of maybe like sentient singularity theory or geometric unity, and then geometric unity could be inside of sentient singularity. Like, but you don't get rid of the term geometric unity, and you don't get rid of the term string theory, because even the languages that each one of these uses, and the style that they use, and the connections made within each theory are unique. So, information theory and music theory are, they would be also part of they would be contextualized within a theory of everything, even. So that doesn't make them wrong. You don't abandon the term music theory or, information theory or evolution. Just recontextualize them. A new perspective on old ideas, not new ideas. which I really liked that Salvatore Pais said that. It's not about, like I said, which is right. It's about which one is fundamental to the others and which ones are useful. That's it. Like, don't worry about like proving one wrong or the other. Like, show where they're useful.
A lot of people say, how dare an engineer enter the realm of theoretical physics where only the gods reside, you know? But sometimes a human being may aspire, you know, to reach Mount Olympus, only to be, you know, struck down by the gods. But still, not trying would be worse. Agreed?
I agree with that.
Thank you, sir. That's all. That's what.
Props to Salvatore Pais. I agree with what he just said. Like, that is like I said, I've never encountered so much ego in my life. In any field. And there is ego in every field, especially academic fields, because they're artificially propped up. And even like herpetology, like, which is a subset of biology studying and ecology, studying reptiles specifically and amphibians. Like, there's ego there that's wild, but it's not the same as physics, and because physics has become a place of untestable mathematical equations, or not untestable, not applicable so far mathematical equations. And whereas, like, even in biology, you can just test things easier. Whereas it's in physics, you can do that too, but we have forgotten we have lost touch with how to do this, and the reason why is because we don't even know what quantum mechanics is anymore. It's the mechanics, that govern the interactions of quanta. Of what? Sentience. Balls of sentience, like me and you and protons. Like, and then there's, information that you can perceive that leads to the symmetries in the standard model and stuff. But we don't think about that in physics at all anymore. Like, what? We're just like, it's an excitations on a fiber bundle. Of what? Of what? It's so ignored. I've played clips of Eric Goldstein and Garrett Lee like talking about the universe appears to have taste, and like they're like dancing around this idea of it being a being, and then neither one of them will actually say it. And and Eric Goldstein even says, he's like, I feel like this is so cowardly, and they just won't. But it's like, stop being cowardly. Just say it. Like, you're just say it. If you don't say it, it doesn't mean Ed Witten is going to come down from Mount Olympus and hear you out about geometric unity. No. So just say it. And if you're honest, you will attract the people that you want to attract. If you're dishonest, you will attract the people that you don't want to attract, or that you shouldn't attract, I would say, even. So like, if you can attract people who you might want to attract, but it's through being dishonest, that is a relationship set to fail already. Don't do that. This is interesting. Talking about the, obviously, remember, Salvatore Pais, he's the author of the UFO patents that
phenomenon. If you really think of...
And he's talking about, in this, the Pais effect and these patents, he's talking about what happens in the phenomenon that he's describing. And I have said on here that I think that warp, or something akin to warp, what we would call like warp transportation, might, or temporal, like maneuvering through temporal dimensions even, you could say. I think that is destructive to the information coherence of the universe. And it's interesting because he's talking about this on this clip, and he basically says something similar, but maybe, I'm not sure. You'd have to flesh it out, but it sounds like it. Here you go.
Schwinger limit. It's really macro, because he's speaking, even though he's speaking of the QED vacuum breakdown. Think what that means. I mean, really, when these electron-positron pairs, when this Dirac sea is being formed, and you well know the Dirac, what that tells me that space-time itself is being torn apart. I have this feeling that this is what this effect is equivalent to. It's like the space-time fabric being torn apart leads, and the Schwinger effect is actually would do that, because it will bring to breakdown.
I think the reason Stephon's asking, correct me if I'm incorrect, is because you said that the Maxwell equations are all that's required for the Pais effect, and he was asking.
Like, I need to delve more into this to make sure that I'm understanding this properly. I might not, because I'm not familiar with all these terms, and it's just like I said, listening to Salvatore Pais is very hard. He talks very fast, and he just, I don't know, there's a lot of information coming out of that guy at any given moment. I'll play a little bit at some point just so you can hear what I mean. And he's just hard to follow, I'll say that. But he's clearly coherent. He just is hard to follow, and he also jumps around a little bit in how he's explaining things, just like I do. So that's not a criticism of him. I do it. But I think he's saying that this gravity manipulation type of thing that's happening, that's also like linked to just high voltage, and I have to go look through the patents again and listen to exactly what he's talking about, but he's talking about his patents, and he's talking about how like the effect that he's involved in the patents, which is like, I don't know what to call it, mass mitigation, gravity manipulation, maybe even like temporal dimension maneuvering, even though it might not seem like that overtly. It might be the result. Like if you're mitigating inertia completely, then you're outside of the effects of space-time. Like you've torn it almost. And I don't know. It's almost, I think about this sometimes, is like, what if everyone got warp all at once? Like, and everybody went to wherever they thought they wanted to. It's like that movie, Jumper, like where Hayden Christensen, and you see like they'll jump and like all of a sudden it'll like create a bridge almost between like two places that weren't already bridged, and it's like everything's now out of context, and you've got cars coming out of the sky and out of nowhere, and ropes going into a wall randomly, like if you're holding onto the rope and you jump inside of the vault or something, and now the rope's going through the wall. It just makes no sense. Imagine we all had this ability instead of cars. Think about the chaos, the informational chaos that would cause. It would destroy coherence. Now, a little bit of like chaos can be tolerated, but not too much chaos. It's like a little bit of cancer, you're not dying yet, but if it's allowed to grow too much, like you are going to fall apart. Same thing with like genetic manipulation and mutation. It's like a little bit won't be immediately observable, at least, but like if you change one gene in you, like maybe you won't even notice. That doesn't mean it won't have made any difference, but like you might not notice, at least in your generation. Maybe it will cause you to, I don't know, your head might shrink into oblivion. Who knows? Depends on the gene. But now imagine every gene in your body, or even third of the genes in your body just changed all of a sudden at one time. It's like, you're just, there goes the universe. Like, there goes you, and you're the universe in this case. I think that this is dangerous. As cool as warp seems would be, and like, I think it's dangerous. Eric Weinstein thinks we need to transcend the bounds of the limits of space-time in order to, escape the rock that we're on, the death trap rock that we're on. And I think he's wrong, but I understand why he thinks that. And I actually think that that would be, if everybody did that, that would be dangerous. Like, you would destroy the coherence of the information of the universe. If too many warps or too many jumps happened and too many bridges were connected that were not previously connected, and they were connected out of context to everybody else. Like, the thing about, like, when you do something in space-time, let's say I like push, I don't know, like this water bottle or throw it across the room. It's not just you. Even they'll say, like, if a bear shits in the wood and nobody's there to see it, like, does it really shit in the woods? But the thing is that implies that there isn't sentient beings there other than the bear. And that's not true, because every molecule in here, potentially, I don't know about these molecules, actually, some molecules might not be sentient, some might be. I'm working on it. But like, the molecules around us and the atoms for sure are sentient. And so imagine if, like, those were just jumped from one spot to the next, versus you threw, like, instead of just like this water bottle jumping from one spot to the next, you threw the water bottle. Even though if I'm alone, I'm not alone. The atoms in this in this water bottle are sentient. So if you just jump them from one spot to the next, like, you're destroying or you're changing their environment in a way that if you were the only one that made that decision, it's out now, they're outside of context. And so you're destroying coherence even in that. Bears cannot shit in the woods and not have anybody else there to perceive it, because the molecules and the atoms inside their shit are sentient. So, but it does get you thinking a little bit. But the thing is it doesn't lead anywhere. So everybody's like, oh, that's an interesting thought. If nobody saw the bear shit, did it really shit? It's like, but if the answer is, like, that's impossible, because even the dirt and the shit and the fur on the bear, the molecules in the fur of the bear, and the atoms within those molecules, and probably the hadrons, and the trees, the cells in the trees, even if not the trees, and the molecules within those cells, and the atoms within those molecules, like, it's all sentient. So if you're just changing things outside of context, it's going to impact way more than just you. And it's not just, like, you can't have a bear shit in the woods and have nobody there to see it. It's impossible. It's a new perspective on an old problem. It's not as Salvatore Pais said. It's just it's recontextualization. There's no such thing as no one there in that situation. There's a bear there, and that bear is made of other sentient beings, which are made of other sentient beings, which are made of other sentient beings, which may be made of other sentient beings, and they are surrounded by sentient beings that are still below organisms, but are still sentient, and therefore processing information in space-time, and you're changing things that are part of their environment. If you throw this, it maintains coherence. Everybody knows what's going on. These atoms in here know what's going on. They don't know, I'm throwing it or whatever. necessarily, but they know like that they're moving, or to some degree, and that there's this their interaction with the information around them stays coherent the whole time. It's contextualized. It went from here to over there, but versus it went from here to there without the journey. That screws things up. I don't think it's good. Okay. 2 more quick clips, and then we're done, and then I'll take questions. This stream was very cool. I really highly recommend listening to it. It's a little complex, and I recommend listening to their actual stream.
In a cosmology, right, we allow actually for these fields, and then sometimes we call these fields moduli, right, because they're associated with the geometry of the internal space. So we have space-time, 4-dimension. We have these other 6 dimensions that can be warped in ways that actually determine the coupling constants in the 4-dimensional world to vary. So then we can take this picture.
That sounds like sentient singularity theory, by the way. Like, that sounds like this. I think we're basically like you have 2 interacting 4-dimensional dimensions, I guess, and then you get 6. So this looks like 9, but it's actually 6 because you have singularity 1, inside 1, or so 2, separate 3, oneness within 4, outside 5, oneness without 6. So, and this is shown in other models that I have of like what I think the observerse is, but I don't know exactly where the model is right now, and I don't want to here, we'll see actually. This binary triality right here, this 6 dimensions everywhere, order of operations in mathematics, everywhere. Who, what, where, when, why, how, rocks, DNA, everywhere. This 6 dimensions is really like, it comes from the interaction between 2 4-dimensional things. So those 4-dimensional things are sentient beings. You can look at colors too. Primary and secondary colors is 6, and it comes from the interaction between one sentient being and another. And so you need 2 4-dimensional sentient beings interacting in order to get 6, because basically what's happening is 3 of the 4 dimensions of each of those sentient beings are overlapping with 3 other of the 4 dimensions of the other sentient being, and it's creating 6. This is the same reason why basically we have like space-time, which is 4 dimensions, but then there's time-space in sentient singularity theory, which is like a God's eye view of space-time, and that's also 4 dimensions, but they overlap with 3 of those dimensions, where one is an intrinsic constraint, which is overlapping always between the 2, and then which is like the present moment would be like if you have length, if you have forwards, backwards, or the future, the past, and the present moment, and then you have space. That's time space. Space would be the extrinsic constraint of the universe, because it is space, like it can't escape it. But then the intrinsic constraint of that would be the present moment in time, and then for us, the intrinsic constraint would be the present point in space. Essentially, you're always where you are, and and then you can go forwards and backwards or left and right or whatever. But then time is your extrinsic constraint. It's like beyond you, whereas like space is the extrinsic constraint of the universe because it's not beyond it. It is it. It's like it's a little different because it is the realm that we're talking about, but it still might as well be beyond it because by beyond it, it means like beyond its control, or completely subject to it, essentially, or surrounded by it, encapsulated by it. Essentially, we're encapsulated and surrounded by time. The universe is encapsulated and surrounded by space, and it can't escape it because it is space itself. But it can't maneuver within space. It maneuvers within time. But like I said, you can watch my video "Space, Time, and the Observerse" where I talk about the universe being fluid, and you can think about it like that, and how it explains exactly this interaction between us and the universe, causing 6 dimensions, perceivable dimensions that couple 2 4-dimensional beings, and that it explains like space-time versus time-space and stuff like that. But this is, I think, what a Calabi-Yau manifold is. But it's interesting to hear him say that. It's like a coupling, he said. That's exactly what I would have expected. It's very... At first, when I used to hear this kind of stuff, it used to give me a lot of anxiety when I started to fall victim to, like, the perspective of, like, the egoic, like, viewpoint that others... that is common in this, at least. Not, I won't say others have and I don't, because I did at certain points, and still sometimes I'll hear somebody say something like, it's an agent, and the gravity is like caused by this capital A agent. It's like, I said that, but then it's like, so did Isaac Newton, and so did, way before Isaac Newton, I went and I told my rabbi this idea. I was like, Rabbi, I think gravity is God moving, literally. And he was like, there's a Kabbalistic concept called tzimtzum, which is like God squeezing together in order to create initially, and that's way older than Isaac Newton. So like none of these ideas are new, and it's actually a good thing. I think physicists should see it and those involved in this discussion should see it as a good thing when other people's theories and ideas are aligning up with theirs. Imagine trying to convince a community that you are worth being paid attention to when your theory isn't able to couple to anything else that is currently being discussed. And I remember talking with my wife about this very early on in this project and speaking like, they're just like when I first saw that, would see somebody else saying something that sounds like my idea. I wouldn't even call it a theory at that point. She was like, that's a good thing. It means like people will be able to understand you. And I was like, yeah, that's actually true. That's a good thing. You want people to be able to start saying these things that could link to geometric unity and autodidactic universe and the Pais effect and, I don't know, conscious agent theory and all kinds of stuff like that. The more connections we make, the closer we get to, the more progress we can make. I will say, I don't want to say the closer we get to figuring it out. I don't like what's there to figure out. I mean, once you realize it's a sentient being, like what is there to figure out? There's plenty to figure out, but about the fundamental nature of the universe, I don't think there's that much to figure out once you realize it's a sentient being. That is the end of it. You've just figured out the nature of reality. It's the nature of you. You're part of reality. It's funny. The only first-person perspective we have of reality is our own personal experience. It makes sense that you should trust your first-person perspective above all else. And if you want to understand the nature of the universe, you should be like, well, what's my nature? Like if you are, people be like, you are the universe. But what is the fundamental nature of the universe? I don't know. What's your nature? Because that would probably be the fundamental nature of the universe. final clip, and then I'll go to questions. But if anybody doesn't want to like engage in this arena and start like figuring out where these theories piece together around each other, like these different puzzle pieces, and they just want to like say that string theory is the only game in town and not go on people's podcasts like that, like then just let them, I guess. Like they'll be left out of the discussion. The discussion's happening, you know? Like I really respect anybody that goes on, like that will go on podcasts that are small too, and like it's not about clout to them, but it is about, you know, I guess you could say just some degree of like professionalism or something like that. I don't want even know if that's the right word, but seriousness, but not like amount of followers or do you have a PhD? You know, I've been seeing a lot of people who are involved in academia a lot more people who are involved in academia, who are these people who are these pioneers that I'm talking about, like John Vervaeke and Yosha Bach and Michael Levin. Like credit to Michael Levin. That guy will probably win the Nobel Prize. Everybody says that, but like I understand why they say that. He really probably will win the Nobel Prize. He goes on tiny podcasts, and that's great, you know, to talk to theists. Here. I might even close with playing some ukulele for you guys. I have gotten better. But it's funny, there like where you couldn't hear is my neighbors playing piano this whole time, and
I guarantee.
But we have to make some predictions.
How is this different than other cyclical?
I noticed that sometimes we'll like play the same song, but like we never talk about it. It's like some little girl, like I've never spoken to her, but like through the wall, like we'll hear each other playing the same song, and but Stephon Alexander, he's a musician too, and I love that he links like music to physics, and I think that that's brilliant. It's like a way of really understanding the universe. I think music is the language that it's more fundamental than any other language that we have. It's the language of pure emotion, is what it is. That's like there's nothing more fundamental as far as languages go than music. What would be a cool experiment would be like hooking the brain up of like a bunch of different animals to, I don't know, maybe some device that monitors the brain activity in some way, and getting a baseline of like what is happy, what is sad, what is scared, what is excited, what is, you know, I don't know, horny, like anything like that, and they're all the baseline emotions, and then playing different music and seeing if that music causes the same emotions across species. So like whatever causes, you know, sadness, like a song that causes sadness just because of the tones and not because of the lyrics, to humans, like would that be able to cause sadness in like snakes? I bet you it would.
Models of cosmology?
Yeah. It's different in the sense of the following. What we were able to show is that if you now couple, right, you couple the coupling constants to the geometry, what ends up happening is that when you get close to the bounce, right, the coupling constant, like a slot machine, they get randomized. And then when you emerge out of the bounce, they freeze. So they get fixed.
Yep.
Right?
Interesting.
So at the bounce is where all the randomization happens, and we can.
Brilliant.
The slot machine gets shuffled, or I call it like an improvisational universe. That basically, you know, in jazz music, the rhythmic structure cycles like a blues, 12-bar blues. It cycles, and every time you go around a cycle, somebody gets an opportunity to solo. And the solo, the improvisation, is basically the shuffling of the coupling concept. That was just the analogy. It's just an analogy that kind of clarifies the equations. So I see the idea is that the reason why
you gotta play your sax. You gotta, yeah.
I'm way out of practice. I'm actually.
That is brilliant to me. And if you've ever seen my animated cosmological verse, that I always put to music in all different ways, and I'm just like kind of obsessed about it. Here. This is it, and I always do put it to music. And what you can see is this kind of what he's talking about, where like there's like this improv that happens. So basically in sentient singularity theory, every time you're moving across one of these, you're forming, like, that's adaptation. And then each time it links to the next level, it's ascension. So like there's a solo happening each time where one being becomes like the head of the assembly and levels up to the next level of life, essentially. So, but there's this improv that happens all here, and then there's this constraint that kind of like keeps it from growing into chaos, but then it can up level at the end of each verse. I call this whole thing a cosmological verse, and I don't know what to call like each individual thing here, but they're basically waves. And but it sounds like kind of similar to what he's talking about, like improvisational universes. This is all adaptation happening here, and then ascension. So this is like people call it microevolution and macroevolution, and microevolution and macroevolution, and microevolution and macroevolution. I call it replication and stacking in my theory. But it's I really like his autodidactic universe idea, and I really like the idea that learning only happens in like an environment that it's allowed and not basically supervised, as he said. But it's not that it's not constrained, but it's free to pursue leads. Like I said, like his theory of the autodidactic universe, I think, is correct in its base assumption, and it holds a lot of lessons that we should think about in regards to like schooling and education. But this is him playing saxophone.
Things about you can't have it that you love to remember, sir. I'm just saying, you forgot to play the saxophone.
Oh, yes.
Beautiful. Until recently, I was not a musician. I couldn't do it. Now I don't know if I'm a musician, but I do play the ukulele decent enough to entertain myself now. Here. This is just a sample of listening to like Salvatore Pais, and just how like he is just difficult to listen to.
Tesla. Now, I know that sounds crazy, absolute crazy. But when you look at the theory, which comes right out of the Oliver Heaviside version of Maxwell's equations, you will know, sir, that Maxwell's equations, the original ones, first of all, they were based on ether vortical theory, and there were 20 equations with 20 unknowns, almost impractical from an engineering point of view. So Oliver Heaviside in the 1890s made possible these 4 equations, 4 unknowns that we all use and love in physics courses in undergrad. He made it possible, because otherwise, if you were to use the correct quaternion formulism that Maxwell brought about, oh my goodness, I'm not sure if you get anywhere soon. So your toe physics.
Yeah, like that. He's just praising Curt there, which, like, good. He should, but it's like it's pretty wild to listen to that guy talk. Like, he just talks. I don't know. Like, he has that like brilliant genius engineering, like almost mad scientist type of vibe going on. So it's difficult. So I can't vouch for like his claim to say that anything that regarding his patents specifically are like that I believe them, or I have no idea. I don't understand. I will say I don't understand why the government would patent that stuff if that was there. I feel like they would. I don't know. Maybe there's some mass disclosure thing happening. I have no idea, and that's just really old at this point. But if it's not, it sounds like it's an effort to throw off China, maybe. But that doesn't mean that Salvatore Pais is not a brilliant engineer, even if those are a disinformation campaign. Like you would want to use an engineer like as to represent them. You wouldn't want to like if it was disinformation, you wouldn't want to choose somebody who wasn't an engineer. But this was a great podcast. I think that there's some things that were said here that I wish they had been more blunt about and picked up on. Like, I don't understand why they didn't start talking about the fact that it's a being. Like, they start or they didn't continue. They started. This is like the continuous conundrum that I see again and again in these physics discussions. By these people who are not accepted by the academic mainstream. They usually don't end up talking about this. A few times I've seen it. On Lex Fridman's podcast, I saw it between Sarah Walker and Lee Smolin. Or not Lee Smolin. Gosh, I always call him Lee Smolin, but it's the guy who did assembly theory. But it sounds like Lee Smolin. It's not Lee Smolin. But like they started saying like, well, why did God create? Maybe he was lonely. It's like, good. Start talking about this. Like, why? Like, when I started looking for evidence of God, physical evidence, I was like, I assumed God's goal was for life to evolve and grow because that's what we see. So then I looked for like the cause of that. And then the cause of that, and 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 like got down to gravity. But I was examining it from a goals perspective. You need to start doing that and anthropomorphizing these things to make serious progress. We're like on the verge, but we have not. Where everybody says it's like a neural network, or it's it's a machine. It's a learning algorithm. The universe, or it's I don't know. Like it's autodidactic. But well, okay, so it's a who, Okay. Just because something is useful doesn't mean it's right. That's true, but it means it's right enough to be useful. So, like, it depends on what you mean by right. Is length, width, and height the three most fundamental triadic dimensions of our reality? No. But is it right enough to where it's useful to, plan building a cabinet? Yes. Forwards, backwards, and current location are more fundamental, but good luck using that to help you build a cabinet alone. You do use that to help you build a cabinet, because it's not just like you need all the dimensions of the things. You also need an order to how you do things, and you also need what would be the goal, and therefore like a way of orienting towards like what is forwards towards completion of the goal. So you need this, sometimes you need these compounding like context in order to do something. So maybe you need sentient singularity theory, and then within that you need I don't know, like geometric unity, or you know, maybe, and then within that you need, I don't know, something else, like whatever's within geometric unity. Like, but they help you along the way, but you don't realize that you're using all of them if you're using them correctly, like building the cabinet. You're not just using length, width, and height. You're also using X, Y, and Z. Where does this go in this 3D space? But also, what is the size of each of these components, length, width, and height? And also, what is forwards, you know, towards the completion of the goal versus backwards away from it? And where am I currently? And also, what is, you know, I don't know, just like, I guess that is the order of operations. But you need these compounding ideas, I guess, or these compounding perspectives on this triadic dimensionality. So length, width, and height is within X, Y, and Z. X, Y, and Z is within forwards, backwards, and current, you know, location. Many things in practice are useful for the paradigm of the goal orientation, but that doesn't mean it is objectively or existentially true. Exactly what I just said. Yeah, you're right. But I mean, I wouldn't even say not existentially true. I would just say it's not as fundamental. But is it true? Yeah, it's true within the context of it being true. I think even asking if something is true or false is within a relativistic framework. All that exists within what objectively exists beyond relativity is that which is. And if you're going to do that, then you have to just orient those things around that which is within it, and contextualize it in its relationship with other things that are. So it's not about which one is true and which one is false. It's like, how is this one connected to that one? How is that one connected to this one? You're already past the point of whether or not you've determined whether or not things are true or false, because everything that is objective and beyond relativity exists. It is. It may only exist within a specific context, but it does exist, and therefore you no longer have to ask whether or not something is true or false. You just ask what is its relationship with this another, you know, how do we orient it within the environment of others, I guess, that have philosophical revelations, but have to hone them in human context and understanding by using these theories that aren't objectively true. It kind of makes me mad when a physicist says that isn't useful, because, well, just because it doesn't help with your furthermost theory doesn't mean it isn't possibly true and more fundamental. That's true. But the thing is, the string theory right now isn't useful. So, like, it's not just about what is useful, but what is useful does help you orient and organize that which you have to deal with. It's like I interviewed once on here Luis Razzo, who has his own theory of everything, and it's like a book that he wrote. And one of the things that we agreed on was that there are serious political and economic implications to a theory of everything, and that you should prioritize your examination of potentially competing theories by which one can have, you know, claims to be able to have an impact on humanity. And I agree with that completely. Like, you shouldn't prioritize those which you can't predict them to have any impact. That doesn't mean you don't pay attention to them, but you don't discount them, but you wait until you can perceive the impact that they may have because it's not useful to you to address it now, which means it's not tied to that which you understand currently, which means you can't contextualize it properly. That doesn't mean you can't come back to it. Like string theory. String theory right now is, I think we'll come back to string theory and we'll be like, dang it, Calabi-Yau manifold, now we understand. But right now it's just, we don't understand. Troll in the dungeon, I see it. Okay. Anyways, everyone, thank you. Hit the like button. If you thought this was useful, comment any final questions that you may have in the chat. But otherwise, I will be wrapping it up here. Again, props to Curt, props to Stefan Alexander, props to Salvatore Pais for this discussion. It was awesome. It's very dense in some places that I don't, and I cannot claim to follow some of the engineering stuff that he's talking about in certain instances. But every now and then, like, something stands out to me. But the beginning part of this stream, if you did not see it, the first clip that I showed is profound, I think, to me. I mean, it works perfectly with sentient singularity theory. And also, I think that it's a really important new perspective that on unification that isn't being discussed, which is that where you unify these four forces within some super force, and then you have to talk about the nature of that super force, which he did talk about, but it went over Stefan Alexander's head. But it's a different narrative than just how do we unify gravity with the other forces. Like, that's not going to work. I mean, if you examine the symmetry of the universe at all, that doesn't make any sense. There's a triality within a singularity that is, it's like inside and outside and separate are all within. They are different perspectives of oneness, and then you could say they are within oneness. But then when they are united within, when you also include oneness in this, then you realize and you contextualize it within that this is an orienting being. That is the super force. Like, it does unify it all. Like, there's no mysteries there anymore. And we can all stop looking for the graviton. But with that, I will be back next week. And like I said, a new video I'm working on should be done. The deadline for it for the competition is Monday. And I'm not doing this for the sake of competition. It would be nice to get $1,000. I'm not gonna lie. But I think that it's just a good opportunity to kind of like, I'm excited for the video that I'm making to explain what is a theory of everything. What because even Eric Weinstein says, like, we don't know what that even means right now, and everybody's got a different answer. I am going to propose an answer in my video, and so that will be dropping probably this weekend. So be on the lookout for that. I haven't made like a video that wasn't live in a long time, but we'll see how it goes. And then this Thursday is our open Discord discussion that we do every week. Private message me on Instagram if you would like the link to that. That's always a really good time. Topic is open. And yeah. If not, then till next week, guys. Thanks a lot, and peace.